All right, 7A, we're going to look at confidence intervals for means. Okay, so what is a confidence interval? Why do we need them? All right, in most situations, we do not have access to population data. It's too hard to get information from every single person or object in a population. So we're often left with using sample data to make an estimate. So here's an example. I want to know the average number of text messages a Patriot student receives in one day. It's going to be way too hard for me to get an answer from every single student at Patriot. So I'm just going to take a random sample of 50 students and ask them, how many texts did you get today? Okay. And then I can find the mean for that sample. So the mean for those 50 people, let's say it was 63.4 and the standard deviation is 12.2. Okay. Now, if it was possible for me to ask every Patriot student how many texts they got, what would that average be? It probably wouldn't be exactly 63.4, but we have no way of knowing exactly what it is. So we do something that's called a confidence interval. And that's just a range of numbers that we can say are blank percent confident contain the true population mean. So I know that my sample mean was 63.4. I'm going to add something to that and subtract something from that and say that I'm pretty sure the real mean, if I could ask every Patriot student, is somewhere between, I don't know, 60 and 66, right? But we're not just going to guess random numbers. There's a mathematical process to come up with that, okay? So that number that I add and subtract, that's called a margin of error, and E is the symbol that's used for that. And then the point estimate, and the symbol there is X bar, that is my sample mean. So my sample average from 50 people, that's my point estimate. And then I'm going to add and subtract some number to that to say I'm pretty sure the real average is somewhere in here. Okay, and the most common numbers we use are 90, 95, and 99%. All right. Another way to think of this is like if you go to Google Maps and ask it for directions at a certain time of day, it gives you a range. Okay, so for me to go from Patriot to Battlefield, they say it's going to take somewhere around 20 to 35 minutes. Okay, we don't know exactly because traffic and lights and everything else, but it's going to be somewhere in that range. Okay, okay, now when we talk about these numbers 90, 95, 99%, okay, the more confident I want to be, the larger I need to make my interval. Okay, so if I'm 95% confident, I might be okay with this time frame, 20 to 35 minutes. But if I want to be 99% confident, like I want to be really, really, really sure, I might make this range a little bit bigger. I might say like 18 to 40 minutes so that I make sure the real number is somewhere in that range. So the higher our percentage goes, the larger our interval needs to be. All right. Now we're going to use Desmos to create these intervals. So here are the steps. So let's go ahead and make a confidence interval for our sample data about Patriot students and text messages. All right. So in Desmos, we're going to click this plus sign. We're going to choose inference. All right. We have quantitative data. Number of text messages is quantitative, and we're doing a z-test. Okay. You have to pick stats over here. We don't want to give it a list of data. We want to just tell it some key stats. So the sample size, we asked 50 students. The sample mean was 63.4, and then the standard deviation was 12.2. And we say create test. Okay, we're not going to do significance tests for now. We're just talking about confidence interval, right? And depending on what confidence level we want, the question will tell you. So if I wanted a 90% confidence interval, that would be my two numbers. If I wanted a 95% confidence interval, I would type that in. Okay, so a 95% confidence interval for the number of text messages that Patriot students receive on average is between 60.02 and 66.78. All right, once we have that confidence interval, we have a sentence that we need to use that's going to explain or interpret that confidence interval. Okay, and so I gave it to you with blanks here. We are blank percent confident the true population, in this case we're talking about mean, all right? The reason I put a blank there is later we're going to talk about something other than mean. Lies between, and then you give the two endpoints that you got from Desmos. So for our text message example, it would be, we are 95% confident the true population mean lies between, and then I use my two numbers from Desmos, 60.02 and 66.78. Okay. We also need to talk about some questions that we could answer. So let's say that a student believes more texts are received on days when there is no school. So they took a random sample of 45 students and found that the average number of texts on a holiday was 66.4. Does that provide convincing evidence that students receive more text on a holiday? Okay, here's what we're looking for. Is that number inside our interval or outside our interval? Okay, so if the average number of texts is 66.4, that fits inside our interval. So because that number does not go outside of what we found, it does not provide convincing evidence that they receive more text on a holiday. So we would say no, because 66.4 is included in our interval. Right, and then the last thing we're going to talk about is minimum sample size. Okay, so if I'm trying to estimate something, I need to know how many people or objects I need to talk to or measure to be able to get a good estimate. All right. The more people you ask, the higher your sample size is, the smaller your confidence interval gets. Because with more people, I can be more confident that I'm getting close to the real number. Okay. But the trade-off is asking more people or measuring more things takes time and money. All right, so we have a formula that we can use to calculate the minimum sample size. So here's the example that we have. They want to estimate within 0.25 ounces for a 90% confidence interval. So here's the formula. Okay, the minimum sample size is equal to ZC, that is the Z-score. So remember we did Z-scores in unit 5, associated with the desired confidence level. So these three numbers, okay, go with those commonly used confidence levels. And I'll give you these, so you don't have to memorize these, but those are, we're going to pick one of those three numbers to plug in for ZC, depending on what the question asks, okay? This sigma is standard deviation, and then E is margin of error, okay? So if I'm going to do this question, all right, so we want a 90% confidence interval. So the number that goes with 90%, the ZC, is 1.645. All right, so I'm just going to use Desmos. 1.645. All right, times standard deviation. So the standard deviation in my paint problem was 0.85. And then to get both of these to be on top of the fraction, I'm going to highlight them and then press the division button. And I'm going to divide by the margin of error. So they asked for a margin of error of 0.25 ounces. All right, so 0.25. Close my parentheses, and then this number needs to be squared. Okay, so my minimum sample size is 31.28. There's a rule for minimum sample size, and that is we're always going to round up to the next whole number. So this is not regular rounding rules. This is go up no matter what. So I got 31.28. My answer is going to be 32. That's the minimum sample size because it has to be at least 31.28. So I need to ask the next whole number of person or measure the next whole number of cans since I can't measure half a can. Okay, and that is it for 7A.